Before we start the show, don't forget to check our new ebook, Kill All Bugs, Learn Software Testing in One Day. For a limited time, it's only $9.99. Links in description.
This episode is sponsored by Walmart. Yup, you heard that right. Walmart. Whether it's your morning coffee run, rushing to work with your headphones on, or that quick evening stop to grab what you need, everything's in one place when it's Walmart. Walmart. Save money, live better. Now, let's get into today's topic.
Welcome back to the Deep Dive. Today, we are really cracking open the engine room of modern development. We're doing a deep dive into Jenkins, the continuous integration server that, well, it fundamentally changed how software gets built, tested, and shipped.
It really did. It's maybe the most established name out there in automation.
Right. And our mission today is to move past the sort of generic definitions and really pull out the crucial stuff, the operational nuts and bolts and the strategic advantages it gives you.
And look, this is essential knowledge because even with all the newer tools topping up, Jenkins often remains that foundational piece. It's the tool that bridges the gap, between dozens of developers committing code, sometimes every hour.
Yeah, that potential chaos.
Exactly, and turns that chaos into reliable automated testing cycles. We're aiming for those aha moments today, not just what Jenkins does, but why its design choices actually matter for the speed and the stability of your whole setup.
Okay, good. So let's start right at the beginning then. For someone who maybe gets version control, like Git, but hasn't really set up a pipeline, how do we define Jenkins at its core?
Well, fundamentally, Jenkins is defined as an open source automation server.
Right.
It's primarily designed for continuous integration, or CI, as everyone calls it.
Right, CI.
Think of it like a central hub or maybe a traffic controller. It's built on Java, and it runs almost entirely on plugins. That plugin architecture is really key to its flexibility.
Okay.
Its main job, it's pretty simple on the surface. Watch the code repository, see a change, and then automatically kick off a sequence, building the code, testing it, and then reporting back.
So it's the watchful eye and the automated trigger, basically.
Yeah, exactly.
Which leads us straight into the concept it really enables, continuous integration. We hear CI all the time. Why is it so necessary? Why isn't it just a nice to have, especially now?
It's all about managing risk. Coordination risk, specifically. Imagine you have multiple developers or even different teams all working on different bits of the same application.
Sure.
If they only merge their code together, say, once a week, you inevitably hit what we used to call integration hell. Just massive, painful merge conflicts. Everything grinds to a halt.
Right, I've heard horror stories.
CI is the solution.
Yeah.
It forces frequent automated merging and testing.
And the key word there is continuous.
Absolutely. Continuous integration is that automated process. It makes sure that every single new change gets merged into the main code base, and then integration tests are run on that combined result. Ideally, this happens multiple times a day.
Multiple times a day, wow.
Yeah, if you don't do that, you might only find out that, the module Team A wrote completely breaks Team B's feature days, or even weeks later. CI catches that breakage almost immediately.
Okay, that really frames the why. So we know what it is, why we need it. Let's talk about, how to get it working. Jenkins doesn't exist in a vacuum, right? What are the absolute must-haves?
Right, it needs two critical things, basically, and both of these need to be part of the code repository itself. First, obviously, you need an accessible source code repository.
Yeah.
Your version control system, or VCS, think Git, which is dominant now, or maybe older ones like SVN. Jenkins has to be able to connect to it, pull the code, see the changes.
Makes sense. And the second thing, that's where the actual work gets defined.
That's right. That's the working build script.
Yeah.
Jenkins sees a change, okay, but then what? It needs instructions. So you have to provide that script, maybe it's a Maven script, for example, and check it into the repository right alongside the code it builds.
So the script lives with the code.
Exactly. That script defines how to compile, how to test, how to package it up. That link is vital. Jenkins needs both the code source and the instructions.
So Jenkins is really the mediator. It sits between the version control system, like Git, and the build tool, like Maven. It's the automated bridge connecting them.
Precisely. When you boil it down, Jenkins is fundamentally integrated with VCS for getting the code and build tools for actually doing something with it. Without those two talking automatically, well, you just have a manual process with extra clicking. Jenkins turns those separate tools into one smooth, automated workflow.
Okay, that makes sense.
Now, this is where it gets really interesting, I think. Why do teams actually invest the engineering time to set all this up? Let's talk about the payoff, the tangible benefits.
Yes, the advantages, because they seem pretty significant. The first one usually mentioned is early bug detection. Why is finding a bug on the CI server so much cheaper than finding it later?
It really comes down to context switching and just time decay. If a bug is caught early, right after the code is committed, the developer who wrote it, they likely still have that code fresh in their mind.
Right, they were just working on it.
Exactly. So by automatically catching bugs at that early stage in the integration environment, you stop them from getting merged into the main branch, messing up other people's work. You avoid someone else having to spend hours, maybe days later, trying to debug old, unfamiliar code. That's a huge saving in time and frustration, and therefore cost.
And when something does go wrong, when a build fails, how does Jenkins help manage that?
Yeah, that's crucial too. Build failures get immediately cached right there at the integration stage. Jenkins essentially acts like a forensic tool.
Forensic? How so?
Well, you know exactly which commit, which developer, probably within a 5 or 10 minute window, caused that build to break. So instead of spending hours hunting for what caused the failure, the team knows instantly and can focus on fixing the known issue. It's a massive shift.
That makes sense. And beyond just fixing bugs, this automation helps organizations move faster, adopt those agile methods we hear about?
Oh, absolutely. By setting up this constant cycle of check-in, build, test, verify. Jenkins directly supports continuous integration, obviously, but also agile development practices in general, and even test-driven development, TDD.
TDD, right, where you write the tests first.
Yeah. TDD is a great philosophy, but it's hard to maintain manually. Jenkins provides the automation backbone that makes TDD practical for a team day to day. It runs those tests automatically on every change.
And that feedback, it's not just in Jenkins, right? It gets pushed out. The reporting aspect seems key.
Communication is critical, yes.
Yeah.
Jenkins is set up to generate an automatic build report notification for every single code commit. It tells you success or failure.
And how does it know who to tell?
Well, that's where integration with the corporate environment comes in. It often hooks into things like the LDAP mail server.
Okay, hang on, LDP. We mentioned it quickly, but maybe not everyone deals with large authentication systems daily. Why is connecting to something like an LDAP mail server important for this notification benefit?
It's vital, really. LDAP Lightweight Directory Access Protocol is typically how large organizations manage user accounts, email addresses, who's who.
Okay.
So by integrating with the LDAP mail server, Jenkins doesn't just send a notification to some static, generic email list. You can actually look up who made the commit, find their official company email address via LDAP, and notify the specific person responsible immediately. It uses the company's authenticated system. So it turns what could be anonymous automation into very targeted, actionable feedback directly to the right developer.
It connects the technical event, the build failure, directly back to the human who made the change.
Exactly. That's the power of that integration.
And we even saw examples listed, like automating a Maven release project. Simple steps in Jenkins can automate what used to be a complex manual process.
Yeah, the overall efficiency gain is just enormous. It frees up developers from doing these tedious, repetitive manual tasks, letting them focus on actually writing valuable code.
Okay, great. Let's shift gears a bit now. From the why to the how, the practical side of managing the tool itself. Let's start with maybe the most basic thing, setting up a new job or project in Jenkins. How does that work?
Well, the UI is designed to be pretty straightforward for this. You go to the menu, you select new item.
Okay.
You give your job a name, something meaningful. Then you usually pick the type. Freestyle job is the most common, most flexible starting point, though you might pick a specific type, like Maven project, if Jenkins has a template for it.
Freestyle, got it.
Then you hit OK, and you land on the configuration page. That's where you tell Jenkins all the details. Where's the code repository? What credentials should it use? Which build script should it run? Things like that.
Pretty standard setup. Now, what about maintenance? You mentioned earlier systems show their maturity here. There are two different ways to restart Jenkins manually, right? Via the URL.
Yes. And the difference between them really tells a story about managing live critical pipelines.
Okay, what are they?
So you have the Jenkins URL, and then you can add restart. That one is the aggressive option. It forces an immediate restart. It does not wait for any builds that are currently running to finish.
Ooh, okay. So that could interrupt things badly.
Absolutely. It's fast, but potentially very disruptive. You'd really only use that in an emergency, like if the server is completely stuck or something's gone seriously wrong.
And the other option, the safer one.
That's the Jenkins URL followed by safe restart. The fact that this command even exists highlights that you can't just pull the plug on these continuous processes.
Right.
Safe Restart tells Jenkins, finish all the builds that are currently running, let them complete cleanly, then gracefully shut down and restart yourself. It prioritizes stability over immediate action.
That distinction really captures that core tension in software delivery, doesn't it? Speed versus stability. You only choose the disruptive speed when you absolutely have to.
That's exactly right. And speaking of stability and maintenance, let's talk about backups and cloning. If you need to back up your whole Jenkins setup, or maybe move jobs between servers, the source material points to a method that's, well, remarkably simple.
Simple how?
Jenkins basically saves all the settings, the build results, artifacts, the logs, everything goes into one main directory. It's home directory.
Okay.
So backing up the entire Jenkins instance, it's literally just copying that one directory.
Just copy the folder.
That's the core idea, which is great for being simple, minimal overhead, but, you could argue that simplicity might be a bit of a double-edged sword today.
How so?
Well, relying purely on copying a potentially massive directory. Think about compliance rules, security scanning, managing storage efficiently, especially in large distributed setups. It shows its age a little, perhaps. Managing just one huge directory for everything might not scale elegantly from a governance perspective.
That's a fair point. It feels very file system centric. But that same simplicity applies to managing individual jobs too, right? Moving them, copying them.
It does. It's all directory manipulation again. Want to move a job, maybe slide it to a different Jenkins server. You just copy the job's specific directory over.
And cloning, like if you want to create a similar job.
Same principle. You just make a copy of the existing job's directory, but give the copy a different name. That creates a duplicate job you can then tweak. And renaming a job, you literally just rename the folder on the server's file system.
Wow, okay. Basic file operations driving the whole CI job management.
Pretty much, yeah.
Now, one specific detail was mentioned about connecting a job to Git, cloning a repository. How does Jenkins authenticate itself to Git?
Right. Jenkins needs credentials, especially for private repositories.
Yeah.
The process described involves the administrator going onto the Jenkins server, switching into the specific jobs directory there, and then running the git config command.
Git config.
Yeah, to manually set the email and username that Jenkins will use when it talks to Git for that particular job. It's how you establish the identity Jenkins presents to the version control system, allowing the automation to work securely.
Got it. So manual config per job sometimes.
Okay.
Lastly, we have to touch on plugins. You said the plugin architecture is key. The source lists a few examples.
Yes, the plugins really define what Jenkins can do. The list gives a good flavor. Things like the Maven 2 project plugin for better Maven integration, Amazon EC2 for cloud stuff, HL Publisher for reports, Copy Artifact to share files between jobs, Join to orchestrate complex workflows.
And the one that jumped out at me, green balls.
Hi! Yes, I love that one. It sounds trivial, but it speaks volumes about developer psychology.
So.
By default, Jenkins shows failed builds with a red ball icon and successful builds with a blue ball.
Glue, not green.
Right, blue. The green balls plugin simply changes the success indicator to green. Why? Because universally, red means stop fail, and green means go success. That immediate, visceral, yes, it's green feedback is actually quite satisfying for a development team.
Huh. A tiny detail, but it affects morale. Instant visual confirmation.
Exactly. It shows how these tools aren't just technical. They interact with how teams feel and work.
It's a subtle nudge. And speaking of plugins, there was one final operational bit about deploying a custom plugin build. We don't need the exact commands, but what does that process tell us about customizing Jenkins deeply?
It tells us that serious customization often means getting your hands dirty with the file system. This is not always a simple web UI click.
Right.
The process essentially involves stopping Jenkins, manually placing the custom plugin file, the .hpi file, into the right plugins folder, removing the old expanded version of that plugin, creating a special empty file, .hpi.pinned, to tell Jenkins, use this specific version I just dropped in, and then restarting Jenkins.
Okay, definitely manual steps.
It just confirms that even for advanced customization, that underlying reliance on the file system structure is fundamental to how Jenkins operates.
Okay, so let's try and pull this all together. We've established Jenkins as this core automation engine for continuous integration. It needs that infrastructure in place, the version control system, and the build scripts.
Right. And crucially, we've seen the strategic payoff. This setup gives you that early bug detection, reliable failure information, and instant feedback loops across the organization, especially using things like LDRE integration. The big takeaway, I think, is how CI, powered by tools like Jenkins, turns the potential chaos of many developers working together into a predictable, automated daily rhythm.
Absolutely. That daily automation is key. And as we wrap up this deep dive, we kept bumping into these interesting trade-offs built into the tool, like the file system backups versus modern governance, or that difference between safe restart and restart. What does the existence of these simple, often manual operational choices tell you, the listener, about the real-world challenges of managing these large-scale, supposedly fully automated software pipelines?
Yeah, that's a great question to ponder. It seems to suggest that automation, well, it never truly gets rid of the need for human judgment, does it? It just shifts where you need to apply that judgment. Maybe less on fixing coding typos, and more on managing the stability and resilience of the automation infrastructure itself.
Something definitely worth mulling over. That's all the time we have for this deep dive into Jenkins. We hope you feel better oriented and strategically informed about how it all fits together. We'll see you next time.
Hey, yo, haven't you checked out our new book yet? Link in description.